So now let's use the power rule. Negative 4 plus 1 is negative 3. And we need to divide it by negative 4 plus 1. Now let's move the u variable to the bottom, and let's move the negative sign to the top. So this is going to be negative 7. On the bottom we have 5 times 3, which is 15, and then u to the third power plus c. Now the last step is to replace the u variable with 5x minus 3. And let's see if I can fit it here. So it's going to be negative 7 over 15 times 5x minus 3 to the third power plus the constant of integration. And so this is the final answer. That's all we need to do in that example. Now, what is the antiderivative of 1 over x? Go ahead and try that problem. Now, if we try to approach this problem like the other problems, instinctively we may decide to move the x variable to the top, and this will give us x to the negative 1. If we use the power rule at this point, it's going to be negative 1 plus 1 divided by negative 1 plus 1 plus c. Negative 1 plus 1 is 0. X to the 0 is 1, but 1 divided by 0 is undefined, and so we're going to have some issues here. So there must be something else that we could do. You simply need to know that the antiderivative of 1 over x is ln x, because if you recall, the derivative of ln u with respect to x is going to be u prime over u. And so the derivative of ln x is going to be, if u equals x, u prime is the derivative of x, which is 1. So it's 1 over x. So if the derivative of ln x is 1 over x, the antiderivative of 1 over x is ln x. So that's one of those formulas that you need to commit to memory. Try this problem. Find the antiderivative of 7 over x dx. Now this is very similar to the previous problem. We just have a number on top. Now let's move that constant to the front. So this becomes 7 integral 1 over x dx. Now we know the antiderivative of 1 over x. You just need to know that it's ln x. And so this is our answer, 7 ln x plus c. Now what about this one, 1 over x plus 5? What is the antiderivative of that? This is going to be ln x plus 5 plus c. Now sometimes, some textbooks, they may have an absolute value with the natural log symbol, because x plus 5 can sometimes be negative for certain x values. And so you might see an absolute value expression here. Now we can get the same answer using u substitution. So if we were to make u equal to x plus 5, du is going to be the derivative of x plus 5, which is 1, times dx. So let's replace x plus 5 with u and dx with du. And so this gives us ln u plus c. And then we need to replace u with x plus 5. And so we get ln x plus 5 plus c. And so you could show your work using both techniques.